Welcome to our NRICH webinar this afternoon. My name is Liz Woodham.
And I'm Charlie.
You're Charlie, and we're also joined by Ems Lord, the director of NRICH.
And Oscar.
And Oscar, I'm so sorry, Oscar. Oscar, who develops all our interactivities. So we're almost a full team. We're delighted that you can be with us this afternoon. At various points, we'll ask you to contribute using the chat, but please do keep your microphones muted and your cameras off for the rest of the event.
I wonder whether somebody has their microphone on in an echo.
There we go. I think that's sorted.
Okay.
This webinar is a little bit different to our usual webinars because we are sharing with you a brand new problem, which we are super excited about. We have put up an image on the screen, which you may have been looking at, wondering about. Well, we hope you've been wondering about it. But in order to introduce the problem more fully and give you a little bit of background, I'm going to hand over to Charlie.
Okay. So I was very lucky in June, I think it was. I was working with some teachers in Spain, and at lunchtime, we all sat down at a big table, and sitting opposite me during lunch break was somebody called Xavi, and he had this interesting T-shirt on that Liz has now put on the screen. Can we have it a little bit larger?
Yes.
So I was intrigued by Xavi's T-shirt. I took a look at it, and I thought there was something mathematical going on. And he confirmed that the 99 circles represented all the numbers from 2 to 100. And I tried to make sense why some were in some circles were in a single color, and some were split into 2, and some into 3, and so on. And once I figured out what was going on, I cut out a little bit of my paper napkin, large enough, made a hole, a window, large enough to be able to cover up all the circles except for 6 circles, so 2 rows of 3. And I stuck the napkin in front of Xavi's chest and got my phone and took a photograph of just the 6 circles that I could see, and showed to Xavi the image, and asked him whether he could work out which numbers, which circles they're represented. And the rest of the meal involved us doing this repeatedly. And when I came back home, Liz and I talked about it, and we thought we could make this into an interesting NRICH problem. And that is what we've done, and that's what we're wanting to share with you. So perhaps we'll give you another minute to have a look at the image. And on NRICH, we've got an image which is slightly clearer. Xavi had this T-shirt for several years, so it was a bit faded. So we've got an image which hopefully is a lot clearer. So we're going to give you just a little bit of time to take a look at it and to see whether you can figure out why the circles appear as they do, given that they represent all the numbers from 2 to 100.
We should say that we're deliberately not going to give you a long time at this stage. Yes, and please be assured, everything, all the images that you are seeing on the screen, everything is already available on the NRICH site. I shall now pop into the chat the link for this problem itself, and then you'll be able to access in everything. Thanks, Charlie. Charlie popped the link into the problem.
Okay, so let's mention that we weren't going to give you very much time. So we thought we would show you the interactivity that sort of mirrors what Xavi and I were doing during that lunchtime. And Oscar has produced this interactivity that you can see on the screen. And we've got a purple cog in the top right-hand corner. And the first option is to show a window. And what you're going to see are 6 circles that appear somewhere on the t-shirt. And the idea is to be able to figure out where in the t-shirt it is. Okay. So let's have a go.
The interactivity is going to give us one as an example. Here we go. Right, Charlie.
At the bottom of the interactivity, it asks us, it says, I know what the circles stand for. And I think I know what the circles stand for, Liz.
Okay.
So shall we see whether...
I'll click here then.
Yes.
Okay, so we're being asked to indicate the value of the circle here with the arrow. Go on then, Charlie.
I think it's 78.
Ooh.
Can you submit? Aha.
Correct. Should we have a go at
Let's do another one?
Okay. Now, it's really important that we emphasize at this point that this is not about speed, but we'll give you a little bit more detail in a second. So here's another one, Charlie.
Okay. And again, I think I know what the circles stand for.
Okay. So this time we're being asked to give the value of this top right circle, the yellow one.
I think it's 73.
73. Very confident. That's correct. So
this is what Xavi and I were doing at lunchtime, and we thought that this would make a nice challenge for students.
Yeah.
Now, I was very lucky. Some teachers at Holier School were very kind and let me loose on their students. And I went to the school and tried this out and with some of the students, and it became apparent that they needed a lot of preparatory work in order to be able to decipher what's going on in those circles. So like Liz said, I didn't do the 2 examples to show off for it.
No.
The idea is that I've been
immersed
in this t-shirt for the last few months. And so I can decode, and I've got information about it, and I know which clues to look at.
Yeah.
So I can decipher what's going on. And I happen to be able to do it quite quickly now because this is all I've been talking to people about for the last few months. But what's important is that the students at Holier did not have that experience. No. And so they were at a loss as to what to do.
Yeah.
So it was a really interesting experience to have with the students because it forced us to think about how do we make the problem accessible to as many students as possible, because we often talk about having low threshold, high ceiling tasks, which are accessible to as many people as possible. So what we want to do is stop showing the interactivity, talk a little bit about what we're offering in the problem to give you some idea about the kind of activities that you might give to students. So in preparation for having a go at the interactivity.
That's right.
Exactly. So we'll come back to the interactivity at the end of this session.
Yeah.
In the meantime, we'll give you a chance to do some of the preliminary preparatory work.
Absolutely. So as Charlie says, I'm going to stop sharing the interactivity, and instead we're going to share the image in a slightly different form. We've given you a link to the task itself on NRICH, and if you happen to have already scanned the activity on NRICH, you'll have noticed that we've linked various sheets. So I'm going to now share one of these sheets with you. So we're going to look at that instead. Let's see, let me have got the right one. Now I need to go back to Zoom. Here we go. Right, I think it's this one. I think that's the correct image I've got. I think maybe making it a little bit smaller would help, Charlie, wouldn't it?
Well, we've got the 100, yes.
Yeah.
Yes.
Bit smaller still, so it's all on the screen, perhaps. Sorry for taking a bit of time to do this. There we go. So we can see the whole image now. So what we'd like you to do is, now you'll see.
Can I just check, at the bottom of the image,
Yeah.
it has asked a question, what do you notice?
Yes.
So the idea would be to give students a copy of this worksheet,
Yep.
which is one of the things I did not have when I went to Hulia. We just had the screen and everybody was staring at that. So they had nothing to scribble on, nothing to make notes on. So to be able to give a worksheet to everybody would be good. And also we've annotated all the circles that have just one color.
Yeah.
We haven't mentioned that they're all prime numbers,
nope.
But we're assuming the students will very quickly figure that out.
Yeah. So that might be one of the things that they notice when they first look at this image that we're putting up in front of them now. We wonder whether you'd like to take another minute now to see what you notice, because we only gave you a very short time. We've also prepared a series of questions and prompts, which we will really hope will help students explore the patterns that they see and develop a really good insight for what's going on in this image. First of all, though, we'll leave you a little bit of time to have a think about what you notice. If you would like to post in the chat, please do. If you are keen not to be interrupted by anybody else's thinking, then please just don't look at the chat. And then in a moment, we will share some specific questions with you, which we hope will help shine a light on some particular, as Charlie used the word clues, I think, some particular clues within the image. It's delightful reading through some of your comments so far, and thank you. What I love about the chat facility in Zoom is it allows you all to interact with each other. It doesn't need, it's just like in a classroom. It doesn't need to be us who respond to everything. It's delightful to see that you're responding to each other. Somebody noticed that 1 wasn't present. That's an interesting point. We've had mention of square numbers. Please don't worry if you're feeling as if you still don't have, you feel like you haven't quite got into this yet. What we're going to do now is I'm going to deliberately scroll down this sheet, and I know that's going to be slightly irritating because you're not going to be able to see the image for a while, but bear with me. If I scroll down.
So this is the second half of a downloadable worksheet, which we assume teachers might print double-sided. So students can have the image of the t-shirt on one side and some prompt questions.
Exactly. Now, if you, what we've tried to do here, as we say, is we have developed a series of questions to draw your attention to particular parts of the image that you've been looking at. Now, some of you have already started to unpick some of these questions naturally, but what we would love you to do now is take a look at the questions as a whole and choose for yourself which ones you might like to try to begin to answer. If you're feeling a little bit at sea still, perhaps I would suggest starting near the top of the questions. If you're feeling more confident, then that doesn't necessarily need to be the case. Once again, any insights that you gain, if you could post in the chat, we'd be very grateful. And let's have a little think, Charlie. We're on 4:20 now. Shall we have 5 minutes? Yeah.
Okay, yes.
Would you like to say anything else?
I'm not quite sure. I don't want to read everything out,
No.
and I don't want to, but it's interesting that, I mean, I think the questions at the beginning about looking at the top row and the 5th and the 10 column are sort of fairly predictable. It was only a teacher recently that suggested the third group of questions, which is that I think 2 is represented by the red circle and 3 is represented by the green circle, and asking us to think about when do other combinations of blue and green turn up, and when do other combinations of blue, green, and other colors turn up, and then the diagonals is interesting because the diagonals is a really helpful thing to think about when we come to doing the windows later on.
Right.
So that is worth thinking about.
And I think perhaps one thing to say before we're quiet for a moment and leave you some time to think. Of course, in the classroom, we would be encouraging students to work in a pair or a small group so that they've got a chance to talk to each other about their ideas. You as the teacher could then be circulating, you could be having conversations with pairs and small groups. And this gives children it gives them a bit more confidence to rehearse their ideas in that smaller, safer environment, in inverted commas, before having to speak out to the whole group. And I appreciate that for you, probably you're on your own at the moment, which is less than ideal. Anyway, should we be quiet for a few minutes if we can? And please do post anything that you discover.
Somebody has asked us to show them the questions again, so I'm just going to scroll down very quickly and then come back to the t-shirt.
Hopefully you've got whatever device you are using, you can have a window with the NRICH website open so that you can be looking at both the questions and the image at the same time. We hope that that's possible. Oh, thank you very much. I think, is that Ems who's posted Julia, thank you, has posted the questions in. Thank you, Julia. We also can see that somebody's asked a question about colour blindness and the colours. We'll come to that in a moment. Thank you.
Yes, in case you didn't get to some of the questions at the bottom, I think there's quite a nice question about the top row having a circle with 3 divided into 3 and all 3 sections being exactly the same color, and how many circles like that are there in the whole t-shirt.
thank you all for your comments in the chat. Let's just bring a few of those together. So Charlie, one of the points that people have been making, I can see here that we've got a circle on the top row which has it's divided into 3 parts which are all a red colour, and then going a bit further down we've got another one which is all green, 3 green parts. I wonder how many others of those I'm going to find.
Those are going to be the only 2, because the first one, the red ones, represent the number 8, which is 2 times 2 times 2, so it's 2 cubed.
Yeah.
And the one which is all in green, between the 17 and the 37, is 27, which is 3 cubed.
Yep.
And the next prime
will
is
be 5,
and 5 cubed is greater than 100. So those are the only 2.
Lovely.
So when it comes to the window exercise that we do,
so if
you ever see one of those, you know, and that's the kind of insight that the Julia students didn't have, because I hadn't given them the opportunity to. And looking at the comments that are appearing in the chat, it seems to me that this crowd are going to cope much better with the interactivity.
I think so.
Because they've had a chance to explore. So. And you can imagine with students having the worksheet and being able to annotate it would be also very good.
Absolutely. And I guess then we could do a little bit of, some of you have been talking about the diagonal, which we were asking about. So this diagonal here, we've got orange.
So that's a multiple of 11. And the reason it's in a diagonal is that to go from one multiple of 11 to another, you've got to go down a row, which adds 10.
Yep.
And 1 to the right, which adds 1. So altogether, you've got to add 11.
So down, across 1, down 1, across 1.
So if you look at 13, for example, which is purple, and if you go down 1 from there and across 3,
1, 2, 3,
you'll get to 26.
Nice.
And you go down 1 and across 3, you'll get to the next multiple of 13.
Yeah.
Whereas multiples of 9, some people have talked about. So multiples of 9 are 3 times 3, so you always get 2 greens.
Of course.
And to add 9, you could add 10.
Go down 1 row.
And then take away 1.
1 to the left.
And again, down and 1 to the left. And 1.
Nice.
And then, so you're always going to get a pair of greens, or at least a pair of greens.
And similarly, I think that might be quite helpful when we have a window, because we can be looking for those diagonals.
Whereas the 5s, for example, which are in yellow here, you just get the diagonals, because as you go down, you're adding 2 5s every time.
Right.
So that's why they repeat. And again, if you get a color repeating itself on a window where the top and the bottom have the same color, if it's not 2s, it might be 5s. Okay.
Okay. And thank you to everybody who has popped in the chat other noticings that you've had along with your reasonings. And of course, this in the classroom, you could bring together as a teacher, sharing those insights and encouraging children to explain why those patterns occur. But Charlie, this was just sort of when we were thinking about how to structure this task, this was kind of, I guess, the first element.
Yes, I wasn't convinced that if we give them just this experience, that students would necessarily be ready to tackle the interactivity. And I want them to have, we want them to have, as positive experience as possible. We talk about students being resourceful and resilient.
Yeah.
Now, in order to be resourceful, you need to have a toolkit, a set of tools that you can bring to a problem. And looking at the comments in the chat, it seems to me that everybody now has got more insights and awarenesses that they can bring to the problem.
Yeah.
And it seems to me you're much more likely to be resilient and prepared to have a go at things if you know you can think about things in a variety of ways.
Definitely.
So we definitely want to make the problem accessible.
Yeah.
We want to give them students as good opportunities to be successful as possible.
Yeah.
And so we thought that maybe one more exercise, preparatory exercise to before the interactivity would be good.
Yeah.
So can we show everybody what we have in mind, which is what we thought we would do, which is to give them a worksheet with some blank circles.
Yes.
And as Liz has said, all these are available in the problem, they're downloadable and so on. We thought that by giving students some blank circles. Are we going to show them the ones where the prime numbers are already?
Yes, that's good. I think what I'm going to do is I'm going to stop sharing and I shall get the sheet up ready.
Okay, so I can talk about, so what we thought was give students, yeah, this one. Okay, oh, they can't see it.
Not yet, sorry.
A blank sheet with the 99 circles and say to the, imagine you were wanting to create your own t-shirt, and in order to do that, the first thing that you would need to do is take the circles and split them up. And we've got 3 versions of this sheet. One has just got the circles without any numbers. One has got the circles with the 99 numbers. And then the third one, which is possibly the most accessible one, is one that Liz is showing on her screen, which has got the 99 number, but also has the primes in bold.
Yeah.
Because one of the things I found was that the students were reasonably confident about the first, I don't know, 10 prime numbers. Yeah. They were much less confident about whether 91 was prime or
right.
not.
And we didn't want to let that get in the way of the thinking that we were helping the students to do. Yeah. Yeah.
So the idea would be to give them this sheet, and again, maybe working in pairs, say to them, okay, can you figure out how you would split the circles that are not prime? And so we wouldn't be worrying about the coloring at this stage. And they might, for example, split the 4 into half, or they might split in half and put 2 times 2 and 2 in each of the halves. And in the 6, they might put a 2 and a 3, and they might go annotating it and so on.
Yeah.
And in the problem, we've suggested that they would stop when they got to about 40.
Yeah.
And the question that we have, I'm going to check on my screen to remind myself what question we have, is a question we're going to ask you, okay, is imagine you carried on doing this till to the bottom of the sheet. Can you anticipate how many circles in the whole t-shirt will be split into 6 sections? So obviously not 6 identical colors. How many of the circles will have 6 sections when they've been split up? So again, perhaps in the chat, you can you can post your response to that question.
We appreciate we haven't given you time to have a go at the splitting yourself, which of course we would anticipate for students.
I like what somebody's posted in the chat, which is a suggestion with a question mark.
Yeah.
And we talk often about how John Mason talks about how important it is to have a conjecturing culture in the classroom.
Absolutely.
Where all statements are treated as conjectures.
Yeah. So we're glad you feel able to do that. So we've got a few suggestions that there might be 2 examples.
And some people have explained why it's 2. So 2 to the power 6, because 2 times 2 times 2 times 2 times 2 times 2 is less than 100.
Less than 100.
So that'll fit.
So they would be all the same color.
They would all be the same color. And the other suggestion, and of course with children we'd have more time, but I'm rushing you because I want to ask you the next question. The other suggestion is 2 to the power 5 times 3. So 2 to the power 5 is 32. And 32 times 3 is 96. So that just manages to fit into the, but anything, you know, I suspect some of you might have tried, I don't know, 2 to the power 4 times 3 times 5, or 2 to the power 4 times 3 squared, and found that they were all greater than 100. And we would want students to be doing exactly that. Great. Okay, so we're rushing you a little bit because we want to give you some time to use all the insights that you're gaining on the interactivity. So the next question that we've got is, can you anticipate how many circles will be split into 5 sections? So you've just been thinking about 6 sections. How about 5 sections? I do like the way some of you, sorry, I mean, um, some of you are posting suggestions using power notation. And of course, primary, you wouldn't expect that from primary age students.
No, you wouldn't.
But
no.
for secondary, in a way, it's quite nice because it, so 2 to the power 5 is going to be 5 sections.
Yeah.
2 to the power 4 times 3, or 2 cubed times 3 squared. And some of you who may be working with secondary school students are doing that. I'm not sure I want to give away the whole answer.
Let's not.
But
let's not.
a lot of people think that there are 4. And I think they're slightly short of the correct answer. Oh, maybe I don't know. Maybe I've got this wrong. No, ignore me. Ignore me. 4 is correct. I'm not telling you. I'm not telling you which 4. I'm sorry. Gee. Okay. I think if the students at Holyoke had had the opportunity to work on this with worksheets. And you and I have been doing some work on resilience recently, and talking about how speed is not of the essence. That we need, rather than focusing on pace, we need to give children space to think. And giving children space to explore, to reason, to talk, to discuss, to share, to explain, to understand, I think gives them the tools to now have a go at
a window and the interactivity. Let's go back to the interactivity. I think that space, not pace, is a really nice little phrase to use. What's the word I'm looking for?
So can we, Liz?
Yes.
When we go back to your screen and the interactivity, can we leave the interactivity that we were on a second ago?
Yes, yes, we can. Yeah. So this is it. I hope you can see this. So this was the last one you did, Charlie, and you suggested that the yellow circle was 73. So perhaps we can have a little look now at the insights that you used.
So what I was thinking...
Well, why don't we just let... 30 seconds, 30 seconds. What do you see here that you think might have helped Charlie? I think reading one of the comments, I think that what we have failed to explain, and that is entirely our fault, so apologies, is that the colours do change. Many apologies. So if we only ever used the colours in our original image, we just felt that children would be relying on memory and not going back to their mathematical thinking. So Charlie is currently pressing the button which says new colours. So this isn't affecting the numbers that are represented on our screen, but it's giving us a different pattern of colours, which may help to address some of the concerns that one of you posted about colour blindness as well, because you can always click through to get a different combination of colours. Apologies that we hadn't said that already.
But also means that if orange was multiples of 2 in the last question, you can't then assume it's going to be, because otherwise, once you've memorized the colors,
precisely,
the whole thing becomes a memory test. Yes. So here yes. So shall I just share my thinking here?
Please do.
So my thinking was, because we're going to set a few for you to do in a similar way. My thinking was, I've got 3 prime numbers here, and apart from 2, prime numbers are always odd. So I can deduce that the left-hand column and the right column are odd numbers, and the middle column are even numbers. And even numbers have always got 2 as a factor, and the color that repeats itself right now is red. So the 2s are reds. Sorry, the reds are 2s. And I can also see on Liz's screen that green appears on this diagonal. And we saw earlier that multiples of 3 or multiples of 9 repeat themselves in this way. And so green must be 3s. So the number in the bottom left, I worked out must be 9 squared. So I knew that was 81. So the one above it was 71, and 2 to the right was 73.
Nice. And as some of you are saying in the chat, this is not the only way of thinking it in the order that Charlie did. Some of you have used slightly different clues or in slightly different order, and that's really important to say. But that's just happened to be the way that Charlie saw it first.
Okay.
So let's give you, before we have to say goodbye, we need to give you a chance to have a go at one on your own. So we're going to press here where it says new game. Okay. I might just change the colours actually a little bit, just so it's a bit more, yeah, good. So have a little think about that one.
Should we point at which circle is
good
going to be
idea? Good idea. If I click here, so we're going to be asked to give the value of this bottom right, sorry, circle.
So we're less interested in the answer, what number it represents. We are more interested in which clues gave away.
Right.
You had a nice way of talking about it. Are you going to remember? Which were the clues that led?
Yes.
That started you on the journey to find the solution.
Right, right. Which some of you have already posted. I can see there are some things in the chat. Yep.
I forgot the microphone off.
No, it's on.
I know that we could be giving you more time, and we're running out of time, and I want to show you what else Oscar has offered in the interactivity. So just very quickly, a lot of people have been saying greens are blue, greens are 2s. I noticed that the pale blues are 5s, and that orange must be 3s, and that tells you that the top middle must be 5 squared times 3, which is 75. And then once you know that that's 75, everything else
85.
falls into place.
86. So we think
And
86.
Oh,
I didn't mean to do that. Never mind.
doesn't. Can you scroll up a little bit, Liz?
Yes.
So one of the problems that I found working with the class is that I was expecting everybody to work at the same speed.
Yes.
Because we just had one screen, we just had the problem.
Yes.
So one of the things that we've done in this problem that we've offered is a link to 8 challenges on a sheet.
Yeah.
And so we've got a worksheet that students could be working on together.
Yes.
Because not everybody works at the same speed. So
yeah,
we talk about low threshold, high ceiling, but we also want to give children time for thinking rather than expect them, everybody should be traveling at the same speed.
Right. And you may have the facilities for them to be doing that on devices in the classroom, but if you don't have enough devices, then a printable sheet is available for you instead.
Yes. Okay, so we got very excited by the Chavi interactivity, and Oscar and us got we then.
So what we were just looking at were the windows.
A block is like the window, but sort of in
a vertical orientation,
yeah.
I guess.
I think we should do a zigzag.
Yeah.
So we know that there aren't many. Oh, and so this is too easy. because that must be 2 to the power 5. But the middle one, the middle top can't be 3 to the power 5 because that would go beyond 100.
Beyond 100.
So straight away.
Yes, that one was a bit easy.
That was too easy.
Well, it was. I mean, we should be clear. It was easy because we are so fluent with this.
But also because we want students to be
all those insights, all those little clues and tools that we've been drawing on as we've been having a go at the different activities. So,
yeah, let's do a new game and see whether we. Oh, this is difficult.
So we must have odd, even, odd.
And we also know that none of those are multiples of 3.
Because otherwise we'd have a match on the diagonal like this. Right. That's
so
good. That's
so
good.
The multiples of 3, and you must always have a multiple of 3 on every row of 3 consecutive numbers.
That's true.
So the multiples of 3 are the 2 circles
that are
missing.
Yes. Here, yeah. So pale blue and purple can't be 3.
No, nor 5 because they would
otherwise they'd be the same. Great.
So one might be 7 and one might be 11.
So say okay. So if this one was 7,
then that would be 2 times 7, but that would
be 15.
So that's
not going to work. So if this was 11,
2 times 11 is 22, and
23.
That would work.
That would work, and this would then could then be
32.
Yes.
Which is 2 to the power lots, so that doesn't work.
So instead 13.
2 times 13.
26. No.
No. Okay, we don't need to do this.
But there we go.
Chavi, I'm not sure what I mentioned. The reason this is called Chavi's t-shirt because the person who was having lunch sitting opposite me was called Chavi. And unfortunately, he can't be here today, but we're going to send him a recording of it. And he knows what he doesn't have is a scarf. But we have created a problem called Chavi's scarf as well. And he says that when it gets cold in Barcelona in the winter, he will wear, he will introduce the scarf to his students. And so Oscar's done interactivity also with the scarf. And if we go to the settings menu, we can see that not only might you get 5 circles in a row, you can also get 4 circles in a row. But also you can have circles with certain number of gaps. So we've got problems like that where there's a gap in between. And so we hope that all the insights that have come from working on the set of questions that we've suggested, working collaboratively, sharing ideas, will prepare students for the harder questions, like the zigzag and some of the scarf questions. We were supposed to finish 5 minutes ago.
We were. So we should say goodbye. Thank you all for participating. We're very grateful for you coming along, to sharing your insights in such an open way. We have, if you are keen to join us on another occasion, you can see that on the events page on the NRICH website. We've put up our future dates, and more details will be available very soon.
I think I want to say one other thing, which is to thank there are people in the group who've joined us today, Sylvia, NRICH, perhaps some of the teachers from Holier School, who have been really helpful in making us think really hard about this rule. Actually, Julia Gogg has also made some suggestions. Yep. We couldn't have done this without your help. It's forced us to think really hard about how to make this an accessible problem. So we want as many students to get the pleasure that we've been getting out of this task.
Absolutely.
So, hope you will enjoy it. If there's anything you think we can do to improve this, you can just email us. At the bottom of any NRICH page, if Liz scrolls down the page, we should find that there are contact details for us. We've had great fun working on this problem. I'm going to be bereft now that the work is complete.
I'm going to pop into the chat the link to the evaluation if you have time to hang on. If not, please, you will be emailed the link by Eventbrite. So please do take the time to give us your feedback. Thank you ever so much, and we hope to see you again. Goodbye.